In this video, we're going to learn how to calculate the amount. That would be the total amount someone would have to pay back on a simple interest loan or simple interest investment. So the balance is actually referred to as the amount, or it can also be called the future value of the investment. It's called the future value because, for instance, if you go back to the problem that we just discussed, the present value of this investment was $5,000, but the future value of it will be the $5,000 plus the interest, which we'll see is $55,33.33. So, as I just said, if you wanted to find the amount owed on that used car loan of $5,000 for a period of 8 months, then we would take the principal, which is the $5,000, and we would add to that the amount of interest that's owed. And so if you add those two together, you get $5,533.33. So really, that gives you a formula to find the amount is simply the principal that's invested plus the interest that's owed on the investment. Now, on the other example, remember we invested $10,000 into an account, and we found that the amount of interest owed was $131.25. So if you take that amount, the $10,000 plus the $131.25, you actually find that the total amount owed on that note would be $10,131.25. Now, we actually can use this to get another formula for amount, and it works simply like this. We know that amount is principal plus interest, and we know that interest is principal times rate times time. So if I take this I right here and replace it with what it equals here, principal times rate times time, I get this new formula, amount equals principal plus principal times rate times time. Now, but since both of these terms have a common factor of p, we can actually factor the p out, and we get a formula like this. So we can say that the amount is simply the principal times the quantity, 1 plus rate times time. And so if we went back and worked that same problem to find the amount, we actually could determine the amount without actually knowing the interest ahead of time. So for instance, as you can see in this formula, all you need here is the same thing you needed before, principal and rate and time. So we know the principal of that car loan was $5,000. We knew the rate was 0.16, and we knew the time was 8/12 of a year, or 2/3 of a year. So if we plug that into the formula, we take 5,000 and then times the quantity 1 plus 0.16 times 2/3. Now here's the catch. You've got to be careful here and make sure you keep that calculation inside these parentheses here. So do this inside an outer set of parentheses. And anyway, when you do this calculation, you should get the same thing we got before using the formula amount equals principal plus I, or principal plus interest. So we get $55,33.33. Now let's do another example. Suppose you want to find the amount due. See, this time I asked for the amount due, not the interest, on a loan of $600 at 15.75% interest after 21 months. Now again, since there's no mention of compounding, we'll assume a simple interest loan. So we know the principal is $600. We know the rate in decimals 0.1575. And we know the time is 21 months divided by 12. Well, 21 divided by 12 is a terminating decimal, 1.75 years. Now, if we plug this information in here, we take 600 times the parentheses 1 plus 0.1575 times 1.75, and again, make sure all of that stays inside this outer set of parentheses. Whoops. Anyway, it's got to stay inside this outer set of parentheses here. And then if you do it right on the calculator, you'll get 765.38. Now you'll notice when I do these problems, I do it in one calculation on the calculator. I don't do pieces of it and then do another piece and then do another piece. So anyway, that is the amount, $765.38. And if you needed the interest from this, you could easily get it. All you have to do is take the amount, $765.38, and then subtract off the original principal of $600, and you can see that this investment earned $165.38. Now, we have basically three formulas here that we've talked about for simple interest, and I can actually solve for other variables here. So, for instance, let's take a look at this problem here. How much would you need to invest at a rate of 6% over a 15-month period in order to have a balance of $3,000? Now, I will show you two approaches, and that should be 2, not TO. But I will show you two approaches to this problem. One approach is just to plug in the given values into your formula. Notice you're actually given that the amount should be $3,000, not the principal, because you want to have an amount of $3,000. So I will take this formula, A equals P times 1 plus RT, and I will plug in for amount $3,000. The principal is my unknown because I want to know how much we need to invest in order so that it will grow to $3,000. So that would be the principal. And then we know the R is 0.06 in decimal, and then the time is 15 months. And if you convert that to years, 15 divided by 12 would be 1.25 years. So what I could do is I could take 3,000 for the amount, and I'd have the principal times 1 plus 0.06 times 1.25. Now, I went ahead and calculated this. 0.06 times 1.25 plus 1 came out to be 1.075. So I simply have that 3,000 is equal to the principal times 1.075, and then therefore to solve for the principal, I just divide both sides by 1.075, and I get that the principal is 3,000 divided by 1.075, and then to the nearest cent, that turns out to be $2,790.70. Now, what you could do, another thing you could do, is you could actually take this formula and solve this formula in terms of P, solve it for P in terms of the other variables, and you would get this formula, P equals A over 1 plus RT. Now, if you did it that way, all you'd have to do is just plug in the value for A, which is, you can see, is 3,000 right here, and then plug in R and T, which is 0.06 and 1.25, and then you could get the calculation directly, but it should give you the same answer. So either approach works. Sometimes it's better to have a formula if there's something that you have to calculate many times, but if you only have to calculate it once or twice, then you probably don't have to worry with it. Okay, now another example is we might have to solve for rate. So look at this problem. It says, what is the annual interest rate earned by a 33-day treasury bill that has a maturity value of $1,000? Now the maturity value is the amount, okay? So that means it's going to grow to $1,000, but since it sells for $916.16, that's the principal. So basically you have a principal that grows from $996.16 to $1,000, and it does this over 33 days. Now remember, 33 days normally would be 33 out of 365, but this specifically says use 360 days for a year. So our time in this case is going to be T equals 33 over 360. Now we already told you that the amount was 1,000 and the principal is $996.16. So if you plug 1,000 in here and then plug $996.16 in for the principal and then plug T 33 over 360, then what I could do here is I could distribute this. 996.16 times 1 gives me 996.16, and then 996.16 times R times 33 over 360 just gives me that 996.16 times 33 over 360 times R. And then if you subtract 996.16 from both sides, see, I can take this and subtract it from 1,000, and then if I subtract 996.16, that'll cancel it over here, and then 1,000 minus 996.16 will give me $3.84. And then, of course, to solve for this R, all I have to do is divide by this expression, and then that'll give me R by itself. So take 384 and divide it by that expression. Now if you do this on a calculator, make sure you put this part in an outer set of parentheses. Okay, so anyway, I got 0.042, which in percent would be 4.2%. Now another way to do this, you could have actually used I equal PRT, and the reason you can do it that way is because you know the amount was 1,000 and the 996.16 is your principal. So if you take the difference between those two numbers, you know the interest is 384. So you could just put 384 in for interest, put 996.16 for principal, and I'm going to move the rate over here, and then put the time here, 33 over 360. But still, I end up doing the same thing. Just take 384 times this 384 divided by this expression, and that'll give me the 4.2%. Okay. Now, on the next video, I've got some just some general problems, simple interest problems that I'll solve for you, and then we'll be finished with this section.